Welcome back to Chapter 3 of our video course on the AI in marketing. In this module, we'll explore some key concepts and real-world examples to help you better understand how AI is transforming the marketing landscape. We will discuss about the classification of AI based on different types of technologies. We'll break down the various categories of AI, such as rule-based systems, machine learning, deep learning, and more. Understanding these distinctions will help you understand the capabilities of AI and how they can be leveraged in different marketing scenarios. Next, we'll dive into a short case study on the Washington Post. Finally, we'll introduce the concepts of machine learning and deep learning, and explore their connections to AI. Machine learning is a subset of AI that involves training algorithms to learn from data and make predictions or decisions without being explicitly programmed. Deep learning, on the other hand, is a more advanced form of machine learning that uses artificial neural networks to model and process complex data, such as images, speech, and text. Let's start with the topic of AI classification. When it comes to classifying AI, it's important to understand that AI is not a single, monolithic technology. Instead, it's an umbrella term that encompasses a broad range of different technologies and techniques. As Professor Michael Luck, Dean of Faculty at King's College London, points out, we often talk about AI as if it's a singular thing, but in reality, it's a diverse field with various components. Rather than categorizing AI into simplistic buckets like strong or weak, it's more accurate to view AI as a collection of multiple technologies, each with its own level of maturity and application. Some of these technologies, such as visual recognition, voice recognition, and natural language processing, have reached a relatively advanced stage and have seen successful real-world implementations, which is why we often hear about them in the media. However, there are also AI technologies that are still in their early stages or require significant further development. For example, expert systems, affective computing, the ability for machines to recognize and respond to human emotions, and artificially intelligent robots are areas where research and innovation are ongoing. It's important to recognize this diversity within the field of AI because each technology has its own strengths, limitations, and potential applications. By understanding the various components that fall under the AI umbrella, we can better appreciate the capabilities and challenges associated with each technology, and how they might be leveraged or integrated within different domains, such as marketing. The classification of AI based on different technologies are: visual recognition. For example, we humans are naturally good at recognizing and understanding what we see in images, whether it's a place, object, or person. However, computers have traditionally struggled with this task. Thankfully, we now have visual recognition technology, which refers to software and applications that can interpret and make sense of visual information like images and videos. One practical application of visual recognition is visual search. This technology allows you to use a real-world image, like a photo or screenshot, as the starting point for an online search. Visual search uses artificial intelligence to analyze the image, understand its content and context, and then provide a list of relevant search results related to that image. A great example is Google Lens. This AI-powered feature in your smartphone's camera can detect and identify objects you point your camera at. Let's say you see a beautiful flower and want to know what type it is. Just point your camera at the flower, and Google Lens will not only identify the specific flower but also give you information about it and even suggest places where you can buy similar flowers. In essence, visual recognition empowers machines to see and comprehend images and objects in much the same way humans do, opening up new possibilities for search, shopping, and accessing information based on visual inputs. Voice recognition. Voice recognition refers to a computer's ability to understand and interpret the words spoken by a human and convert that speech into a format that machines can process. This technology allows devices to interact with people using natural language, enabling them to understand human questions or commands and respond accordingly. Voice AI assistants like Amazon's Alexa, Apple's Siri, and Google Assistant are great examples of voice recognition in action. These virtual assistants can comprehend your voice commands and have conversations with you. By understanding human language, voice AI chatbots provide businesses with an opportunity to better serve customers. They can handle inquiries, speed up processes, boost productivity, and scale operations more efficiently. Voice recognition is allowing us to move beyond touchscreens and interact with devices using just our voices, which is incredibly convenient. Experts predict that voice-based shopping and commerce will grow dramatically, potentially reaching $60 billion by 2024, as people get more comfortable making purchases through voice commands. In simple terms, voice recognition empowers machines to comprehend human speech, enabling natural language interactions that make our lives easier and more efficient across various applications and industries. Natural language processing. Natural language processing is a branch of artificial intelligence that deals with analyzing and understanding human language data. It involves taking natural language inputs like speech or text and converting them into a format that computers can easily process and understand. Speech recognition and AI play crucial roles in natural language processing by improving the accuracy and efficiency of recognizing and interpreting human language. Natural language processing is what enables smart devices and digital assistants like Alexa, Siri, Google Assistant to understand and respond to our voice commands, whether it's setting reminders, controlling smart home appliances, or even recognizing songs playing nearby. Search engines also use natural language processing to better comprehend user queries and provide more relevant search results. Many businesses now integrate speech-to-text software powered by natural language processing into their applications and services to streamline customer interactions and experiences. With natural language processing and speech recognition, companies can transcribe calls, meetings, and even translate conversations between different languages automatically. Major tech companies like Apple, Google, Facebook, Microsoft, and Amazon are at the forefront of developing advanced natural language processing and speech recognition applications to enhance user experiences across their products and services. In essence, natural language processing combined with speech recognition enables machines to effectively communicate with humans using natural language, making interactions smoother and more intuitive in our increasingly AI-driven world. Expert systems. An expert system is a type of computer program designed to solve complex problems by mimicking the decision-making ability of a human expert in a specific domain or field. These systems contain a vast knowledge base that stores facts, rules, and information about a particular area of expertise, such as medicine, science, or engineering. When a user presents a problem or query to the expert system, it uses reasoning and inference rules to analyze the knowledge base and provide solutions or recommendations, just like a human expert would. The system relies on both factual knowledge and experience-based techniques to make intelligent decisions, similar to how human experts use their accumulated knowledge and intuition. Expert systems are called expert because they encapsulate the specialized knowledge and problem-solving skills of experts in a particular domain, allowing them to solve complex problems within that specific area. For example, PXDES is an expert system used in the medical field to determine the type and severity of lung cancer. It analyzes images of the upper body, like X-rays or CT scans, and identifies any concerning shadows or patterns that could indicate the presence and extent of lung cancer. Affective computing. Affective computing refers to technology that can automatically recognize, interpret, process, and simulate human emotions and feelings. It's essentially the study of systems and devices that can understand and respond to human emotions. Understanding emotions is crucial, especially for companies selling complex products or services, because emotions often guide our subconscious decision-making processes. Research shows that emotional, instinct-based decisions can sometimes be more effective than conscious, logical decisions when it comes to complex choices. With affective computing, machines can analyze vocal inflections and tone to detect emotions like stress or anger in a person's voice. They can also study facial expressions and micro-expressions and subtle facial movements that may be too brief for humans to notice, but indicate specific emotions. A practical example is Companion MX, a mental health app that listens to users speaking into their phone. It analyzes the speaker's voice and phone usage patterns to identify signs of anxiety or mood changes. The app then provides users with insights into their emotional state and coping strategies, like stress reduction techniques, to improve self-awareness and mental well-being. In essence, affective computing enables machines to understand, process, and respond to human emotions, opening up new possibilities for more emotionally intelligent and empathetic technology across various domains, from mental health to customer service. Artificially intelligent robots. Robotics is the field of engineering that focuses on designing and building robots to perform tasks automatically without human intervention. Traditionally, robots have been used for tasks that are too difficult, dangerous, or repetitive for humans to do efficiently. However, combining robotics with artificial intelligence allows for the creation of artificially intelligent robots that can do much more than just automated tasks. AI gives robots computer vision capabilities to navigate their surroundings, sense and perceive their environment, and calculate appropriate reactions accordingly. These robots learn how to perform tasks from humans through machine learning techniques, which are part of AI and computer programming. What makes AI-powered robots powerful is their ability to think and make decisions on their own, beyond just following pre-programmed instructions. Companies are increasingly exploring ways for robots to move past simple automation and tackle more complex, high-level tasks that require decision-making and adaptation. A great example is Sophia, an advanced human-like robot created by Hanson Robotics. Sophia personifies our dreams for the future of AI and robotics. Not only is she a unique work of engineering artistry, but Sophia is also a platform for cutting-edge robotics and AI research, showcasing how far we've come in developing intelligent, humanoid robots. The next tech. The next tech is an umbrella term that refers to a collection of cutting-edge technologies that are being actively used by marketers today. These technologies include artificial intelligence and natural language processing, sensors, robotics, augmented reality, virtual reality, mixed reality, the Internet of Things, and blockchain. By replicating and enhancing human capabilities, these technologies have the potential to revolutionize the field of marketing and enable next-generation marketing strategies. Out of all these technologies, artificial intelligence is one of the most popular and buzzworthy, and for good reason. AI has proven to be an extremely powerful tool with numerous marketing applications. While AI has been around for decades, its recent surge in popularity and adoption can be attributed to three major factors. The growth of big data and availability of massive datasets to train AI models. The accessibility of cheap and scalable computational power through cloud computing and specialized hardware. The development of new and advanced AI techniques, such as deep learning and neural networks. Importantly, AI is not just a standalone technology, it has the ability to enhance and supercharge many of the other next-tech technologies. For example, AI can power intelligent sensors, enable more advanced and adaptive robotics, enhance the realism and responsiveness of mixed reality experiences, optimize IoT systems, and even secure and streamline blockchain networks. Story of the Washington Post: How AI has changed the Washington Post. The Washington Post is a renowned newspaper founded in 1877 and based in Washington, D.C. It's the most widely circulated paper in the D.C. metro area and has a rich history, including publishing groundbreaking stories like the Pentagon Papers and Watergate scandal. However, by the late 2010s, the newspaper was facing significant financial losses. In 2013, it was acquired by Nash Holdings, a company backed by Jeff Bezos, the founder of Amazon, for $250 million. Under Bezos' ownership, the Washington Post embraced the power of artificial intelligence and machine learning to revitalize its operations and stay competitive in the digital age. One of the key implementations was using AI and ML to predict the popularity of articles. This allowed the newspaper to better understand reader interests and tailor its content accordingly. The newspaper also developed a system called Zeus Insights, which acts as a personalization engine, using AI to recommend the most relevant articles to individual readers based on their preferences and behavior. To moderate the high volume of comments on its website, the newspaper deployed an AI-driven comment moderation system. This automated system can quickly filter out abusive or inappropriate comments, saving human moderators significant time and effort. Perhaps most impressively, the Washington Post created an AI-powered story writing system called Heliograph. This system can autonomously generate straightforward news stories, such as weather reports or minor league baseball recaps, by analyzing data and following predetermined templates. According to the newspaper's leadership, the AI-generated stories produced by Heliograph were often better than those written by human reporters for these specific types of routine, data-driven articles. By embracing AI and ML technologies, the Washington Post has not only streamlined its operations but also enhanced its ability to deliver personalized, relevant content to its readers, while freeing up human journalists to focus on more complex, investigative stories. This transformation serves as a powerful example of how legacy media organizations can leverage AI to adapt to the digital age and remain competitive in an ever-evolving media landscape. AI dimensions. AI field has developed in two dimensions. Human-centered, based on hypothesis and experimental validation. Rationalist approach, based on engineering and mathematics. Human-centered approach. This approach is rooted in empirical science traditions, relying on forming hypotheses and conducting experiments for validation. Human-centered AI systems learn from human input and collaboration, with algorithms designed to work as part of a broader human-based system. These systems continuously improve through ongoing human input, aiming to provide an effective human-robot interaction experience. By developing machine intelligence focused on understanding human language, emotions, and behaviors, human-centered AI bridges the gap between machines and humans. From a business perspective, human-centered AI solutions leverage human sciences and qualitative data to understand customer needs, aspirations, and behaviors in a market. Advanced contextual analytics combine data and human sciences to deliver specific insights into human behaviors and choices, revealing patterns that can enable personalized customer experiences. Rationalist approach. This approach involves a combination of mathematics and engineering principles. AI is a discipline dedicated to developing software and hardware capable of performing cognitive activities by simulating human behavior to achieve optimal results, even in uncertain scenarios. From the rationalist perspective, any technique that enables machines to act like humans and make decisions qualifies as AI. In the early days, a major challenge was performing tasks that are easy for humans but difficult to formally describe in mathematical rules. This difficulty indicated that AI techniques needed the ability to extract patterns from data and acquire knowledge on their own, leading to the development of machine learning. Machine learning enables applications to automatically detect patterns in data and act without being explicitly programmed, mimicking human learning. AI has advanced not only in simulating human behavior through predefined rules like classical AI algorithms but also in mimicking human learning capabilities. The human-centered approach aims to understand and replicate human intelligence through observation and collaboration, while the rationalist approach relies more on mathematics, engineering, and formal logic to develop intelligent systems that can learn and perform cognitive tasks autonomously. Machine learning is a subset of artificial intelligence that focuses on developing computer algorithms that can learn and improve automatically through experience and data exposure, without being explicitly programmed. The core idea behind machine learning is to create algorithms that can mimic the way humans learn, by studying examples, recognizing patterns, and making predictions or decisions based on those patterns. As these algorithms are exposed to more data over time, they can gradually refine their models and improve their accuracy, just like humans get better at a task through practice and experience. Machine learning finds practical applications across many domains in our daily lives. Some of the common examples include spam email detection in services like Gmail, where the system learns to identify spam messages based on analyzing past emails marked as spam or legitimate. Speech recognition capabilities in virtual assistants like Siri, Alexa, and Google Assistant, which improve their ability to understand human speech through exposure to more voice data. Computer vision for augmented/virtual reality tools, which use machine learning to better interpret and understand visual data from the real world. Estimated delivery times provided by apps like Zomato or Uber, calculated by machine learning models that analyze historical traffic and delivery data. The key process in machine learning involves feeding sample data into the algorithm, which then builds a model capable of making predictions or decisions without being explicitly programmed for every possible scenario. As the model is exposed to more data over time, it can continuously refine and improve its accuracy, making machine learning a powerful tool for automating and enhancing various tasks. In essence, machine learning brings artificial intelligence closer to replicating human-level intelligence by enabling systems to learn, adapt, and improve autonomously, just as humans do through experience. The basic approaches of machine learning are supervised learning, unsupervised learning, and reinforcement learning. Now we will explore each topic in detail, starting with supervised learning. In supervised learning, the data provided to the machine learning model contains both the input data and the corresponding desired output or labeled data. A common example is visual recognition systems, where the model is trained on a large dataset of images that are labeled with the objects they contain, like car, dog, building. By analyzing these labeled examples, the model can learn to recognize and classify new images it hasn't seen before. Before training begins, a data scientist or domain expert needs to manually label the training data by associating each input data point, like an image, text, sensor reading, with the desired output, like object class, sentiment, numerical value. A simple analogy is training a machine to identify different types of fruits. First, you show examples of fruits to the machine and tell it their names. This round red one is called an apple, this long yellow curved one is a banana, and so on. Next, you feed all these named fruit examples to the machine's learning system so it can study the features of each fruit type. After studying the examples, the machine becomes smart. Now when you show it a new fruit it has never seen before, it can identify and label it correctly using what it learned from the previous examples. There are two main types of supervised learning problems. Classification, predicting group names or labels like fruit or not a fruit. Regression, predicting numbers, like how much a fruit weighs. The great thing about supervised learning is that by studying many labeled examples, the machine can make reliable predictions. However, getting lots of good labeled examples can take a lot of time and effort. The next is unsupervised learning. In this method of learning, the data provided to the model contains only the input data, without any corresponding output or labels. The model's task is to find patterns, structures, or relationships within the input data on its own, without any guidance from labeled outputs. A good example is clustering algorithms used to group similar data points together, such as identifying different clusters of COVID-19 cases based on various input factors. Unlike supervised learning where a teacher shows examples and gives instructions, there is no teacher guidance in unsupervised learning. The machine has to learn on its own without any training. Imagine the machine is shown pictures of apples, bananas, and mangoes, fruits it has never seen before. It has no prior information about the features or names of these fruits, so it cannot label them as apple, banana, or a mango. However, the machine can study the pictures and group them based on their similarities and differences in color, shape, size, etc. It can put all the apple pictures in one group, all the banana pictures in another group, and all the mango pictures in a third group. It does this on its own by detecting patterns in the unlabeled data, without any previous examples or training on what an apple, banana, or mango looks like. The machine essentially discovers and teaches itself. Unsupervised learning allows the machine to identify previously undetected patterns and information from unlabeled data, without relying on pre-labeled examples. It explores the data independently to find the hidden structure. The two main categories of unsupervised learning algorithms are clustering and associations. In clustering, the machine groups similar data points together into clusters or groups. It's like sorting different items into piles based on their shared traits. For example, it can group customers into different clusters based on their purchasing behaviors and patterns. Customers who buy similar products or have similar spending habits would be put into the same cluster. Association: here, the machine tries to find relationships or associations between different data points. It looks for rules that explain larger portions of the data. For instance, it may discover a rule like, people who buy product X also tend to buy product Y. This helps understand which products are frequently bought together by customers. And finally, reinforcement learning. Here, learning is an approach where the machine learning model interacts with a dynamic environment and learns through a process of trial and error and receiving feedback like rewards or penalties for its actions. The model is not explicitly told what actions to take but must discover the best strategy or behavior through repeated experimentation and observations of the consequences. A prime example is self-driving car systems, where the model learns to navigate and make driving decisions by continuously perceiving the environment, taking actions, and receiving feedback like staying on the road, avoiding obstacles that reinforces optimal behavior. Through this process of exploration and reinforcement, the model gradually learns to maximize its rewards and achieve the desired outcome. It's like a game where the machine, or software, has to figure out the best moves to make in order to get the highest score or win. The key difference from supervised learning is that in supervised learning, the training data already has the correct answers, so the model learns from those pre-labeled examples. But in reinforcement learning, there are no predefined correct answers. The machine has to learn through trial and error, by taking actions and seeing what outcomes, rewards or penalties, it gets. It starts out knowing nothing, and over many iterations it figures out which sequence of actions works best for completing the task successfully and maximizing the reward. So, it's like exploring a new game by playing it repeatedly, learning from its mistakes and successes, until it discovers the winning strategy on its own through reinforcement from the environment. Now we will discuss about deep learning, a machine learning technique that teaches computers to do what comes naturally to humans, like learn by example. Deep learning allows computers to learn and make decisions directly from data like images, text, or audio, without being explicitly programmed on what to look for. It is the key technology that powers modern AI applications we use daily. For example, self-driving cars can recognize stop signs, pedestrians, etc. thanks to deep learning. Voice assistants in phones/speakers understand voice commands using deep learning. Deep learning models achieve very high accuracy, sometimes even better than humans, by exposing them to large datasets during training. The more data they learn from, the smarter they get. Unlike traditional computer programs with fixed rules, deep learning models have many layers that allow them to automatically learn the relevant features and patterns from the data itself. This automated learning ability is why deep learning gets a lot of attention lately. It can solve complex problems that were very difficult before. In simple terms, deep learning gives machines the amazing power to learn, recognize patterns, and make decisions in a way similar to how the human brain learns, by exposure to data examples rather than manual programming. Now we will discuss where deep learning is used in practice. Starting with customer experience. Many businesses use deep learning for better customer service, like chatbots and self-service solutions. Deep learning powers the language understanding and natural interactions in virtual assistants. Language translation. Deep learning models can automatically translate text between languages. It is enhancing translation accuracy by using advanced neural networks. Some models can even translate text from images. Speech recognition. Deep learning helps recognize and distinguish different dialects of a language. It can detect if someone is speaking English, then bring in an AI trained on that specific dialect. This allows understanding diverse accents and speech patterns without human input. The key difference between AI, ML, and deep learning is the level of human guidance required. In traditional AI, humans define all the rules and logic. In machine learning, humans provide data and extract relevant features. In deep learning, the model automatically learns features and patterns from the data itself. So as you move from AI to ML to DL, the amount of manual human effort reduces. Deep learning requires minimal human involvement to define or extract features from raw data. In simple terms, deep learning is an extremely powerful way for computers to learn directly from data, with little human supervision needed. This automated learning capability is revolutionizing many fields. Connection between AI, ML and DL, understanding the relationship. The figure shows how deep learning is a kind of representation learning, which is used for many but not all approaches of machine learning, which in turn is considered a kind of AI. AI is the broad concept of machines being able to mimic human-like intelligence. Machine learning is a subset of AI, where algorithms learn from data to make predictions or decisions, instead of relying only on hard-coded rules. Deep learning is one specific technique for implementing machine learning. It is a powerful representation learning method that automatically learns increasingly abstract data representations across multiple layers. To illustrate with an example of product recommendations. Classic AI would use hard-coded rules like recommend top purchases. Machine learning could learn patterns from user age, product categories, etc. Deep learning takes it further by automatically learning the most relevant features from raw data inputs. The key difference is the level of human involvement. In AI, humans define all the rules. In ML, humans provide data and extract handcrafted features. In DL, the model learns the relevant features itself from the data. So deep learning reduces human effort by automating the process of learning useful representations directly from data, across multiple layers. This allows very accurate predictions. In simple terms, deep learning sits at the intersection of being an advanced machine learning technique as well as a way to represent and make sense of raw data inputs, with minimal human feature engineering required. To sum up, artificial intelligence is transforming many industries, and marketing is no exception. Machine learning and deep learning techniques are allowing marketers to better understand customer behavior, personalize experiences, optimize campaigns, and drive more effective strategies. From predictive analytics to natural language processing and computer vision, AI continues to open up new possibilities for hyper-personalized and intelligent marketing at scale. As these capabilities evolve, marketers who embrace AI will gain a significant competitive advantage. I hope this course provided you with a solid foundation for leveraging AI in your marketing efforts. If you found it insightful, don't forget to give this video a like. Also, hit that subscribe button and click the notification bell to stay updated. We'll continue exploring cutting-edge AI applications in marketing through upcoming videos. Thanks for watching.